Welcome to Wings of Aero. I'm here to help you guys with my best subject knowledge and ideas with you, so stay tuned to my channel. Today I'm gonna lay out about the Airfoil Nomenclature, followed by NACA Series, and then advantages, disadvantages and application of various series, NACA series, and few solved MCQ questions. First, in introduction, what is mean by airfoil? So airfoil is a cross-section shape of a wing. When it is moved through an fluid or an air, it produces an aerodynamic forces. It has been designed in such a way that it creates a curved streamline which helps to create a low pressure on the bottom and the high pressure at the top. So here comes a few nomenclature: leading edge, trailing edge, camber, chord line, camber line and thickness. So first, what is meant by leading edge? You can see which is in the front of the airfoil and having a maximum curvature but make a point but a minimum radius. That particular point is called as a leading edge. Next comes trailing edge. Similarly, where the point of curvature is maximum, or we have a maximum curvature at the rear of an airfoil, we call as a trailing edge or the rear part of an airfoil. What is chord line? Straight imaginary line connecting between the leading edge and the trailing edge and defined as a alphabet C, small c. This is actually for reference dimensions. Mean camber line. This mean camber line, or we can also call as mean line, it is actually a locus of a point midway between the upper curvature and the lower curvature. It depends on the thickness distributed within the along the chords. So what is meant by thickness? Thickness is this varies along the from the leading edge to the trailing edge. The thickness measure perpendicular from the camber line. It has been measured perpendicular from the camber line. The airfoil can be classified in two forms. One is in symmetric, another is a cambered airfoil. So symmetric airfoil, let's see here. So both the upper curvature and the lower curvature will be same. And when we see by increasing the angle of attack with the effect of CL, we can see at zero angle of attack, the CL will be also zero. By increasing the angle of attack, there will be some amount of lift. But at certain point here, it will lead in maximum lift at certain alpha. We consider as 15 to 22. Beyond that, if we increase the angle of attack, it will leads to stall. Similarly, in camber, we can see at zero angle of attack, there is some positive lift. So in case of zero angle of attack, here is a 0 point. At zero angle of attack, we have some positive lift of an camber airfoil. Here is a combination of camber and the symmetric airfoil has been described. Now comes to NACA series. Here we have few types: 4-digit series, 5-digit series, 1 series, 6-digit series, 7 series and 8 series. But as per our syllabus, we have only 4, 5, 1 and 6. Let's focus into it. Now comes the 4-digit series. So NACA we have 4-digit. You can see here, consider this a 1, 2, 3, 4. Here the first digit expresses that is how much percentage of camber present. If here we have 1, that is 1% of, that is a 1% of maximum camber present in a particular airfoil. Now consider second digit, that means how far, that is location of maximum camber from the leading edge into 10%. Suppose here the digit is 2, then it will be 20% of the chord, that particular location we have the maximum camber. And always the last two digits explains the maximum thickness to chord ratio. That is, if we have here 1 and 2 here, so we have a 12% chord thickness to chord ratio. Now comes fifth digit series. We have 5 digits. The first one represents a CL. The first digit represents a CL. How you can find CL? If here we have 1, so we just assume here we have 1. So what we can write, that is how much amount of CL? That is 1 into 0.15. That is 0.15 of CL will create on this NACA airfoil. Next comes location of maximum camber from the leading edge into 3. So suppose here you consider 2. Okay. So in the second digit 2 means it is 2 into 3, you will get 6. That is 6%. That is 6% of the chord at that particular point, it will have its maximum camber. In the third digit express that either it can be a 0 or 1. If 0 explains the camber is simple and the 1 represents it is a reflex camber. And the last two digit is always the same, it denotes the maximum thickness to chord ratio. Next comes, in 1 series and 6 series there will be one thing called hyphen. So using that you can identify or differentiate between the 1 series and 6 series. So let's come to first series here. This is the format. So in the format, the first one indicates what is the series. So here we have 1, so it comes under 1 series. The second alphabet denotes, or second number denotes, the maximum pressure area distance on the 10% of chord. If we have 2 here, that is 20% of pressure distributed of distance in of the chord. This is a hyphen. Then comes the X. This third value represents the lift coefficient. If we have 3 over here, then we have to 3 into 0.1, we will get a 0.3 of lift coefficient. And last two digit is always same, that is percentage of maximum chord thickness to chord ratio. Here comes a 6 digit series. See, there is a far difference between 6 series and the first series. Here we have another small X here. That's the only difference. And also the hyphen. It's a common thing. So usually the first one denotes the indicate the series, and the second one also the same, indicates the maximum pressure area distance from the chord, and the small one X denotes the drag. How much amount of drag? If here we have 2, that is 2 into 0.1, you will get as, if 2 into 0.1, you will get as 2.2 drag. Lift. So here the first one after hyphen we have a coefficient of lift. So how, if here we have around 1, so what will be a lift coefficient? 1 into 0.1, you will get 0.1. The last two digit again the same, the maximum thickness to chord ratio. Here are a few advantages, disadvantages and application for helicopter blade. We use 4 digit and it's constant, that 0012 we use for helicopter blade. And for missile and rocket fins we also use 4 digit. Because what is a maximum benefit? It is a maximum benefit is for good stalling effect. But whereas in 5th and 6th, whereas in 5th digit we use in business jet, piston and general aviation. And the 6th series for especially for supersonic jets because we need to form a high lift. Now it's time for solve MCQ. So first question, for an symmetric airfoil the lift coefficient for zero angle of attack is. So recall the diagram for symmetric airfoil. So you can see at zero angle of attack the CL also 0. So right answer is answer B. Find out the design lift coefficient for NACA 23016 airfoil. So first recall this 5th digit series. We have 523016. So we know that the first digit represents the lift coefficient, it is 0.3. Whatever the value you have to multiply with 0.15. Location of maximum camber, that is 3 into 3, that is you will get as 9% of chord. The 0 represents we have a simple camber, and the last 2 digit represents the thickness to chord ratio, that is 16%. So our right answer here in this question, they have asked a lift, so the right answer is answer B. The geometric features of symmetric airfoil are rounded leading edge, flat upper surface and high camber at the rear. Sharp leading edge, flat upper surface and high camber at the rear. Rounded leading edge, curved upper surface and no camber at the rear. Sharp leading edge, curved upper surface and no camber at the rear. So if you consider a symmetric airfoil, so we know always it has a round edge, leading edge, and the second is for symmetric no camber is present. So from here we can choose our right answer is answer C. Next, find out the maximum camber for NACA 00164 4-digit series airfoil. So from here we have to find the maximum camber. So you know the formula, how to find the maximum camber, that is a first series, it is percentage of camber, that is we have 0. So our right answer is A, 0.00 of chord. Estimate the maximum thickness in percentage of chord for NACA 16-214 airfoil. See here in this question we have 1 at the first and the hyphen, so it comes in the 1 series. So we can see what they asked to find the maximum thickness. So we know the last 2 digit represents the maximum thickness to chord ratio. So our answer is 14%. Our right answer comes as option D. NACA 0015 implies symmetric, positive cambered, negative cambered and cups type. So we know the first 2 digit, if first 2 digits come 0, that means the camber is absent, that is it is an symmetric airfoil. So right answer is A. Maximum thickness of NACA 12045 airfoil. So again you have to find the maximum thickness. So how you can find? See, this is a 5th series. So last 2 digit, that is we have 45. So right answer is 45, that is B. Then lift coefficient for NACA 61-315 airfoil. So this is an, from the question we can see this is an 6 series NACA airfoil. So let's focus on the 6 series 61X-315. What they asked to find? They asked to find what is a lift coefficient. So we know that this series belongs to the lift coefficient. So corresponding to this value into 0.1 we will get the coefficient of lift, that is 0.3. So our right answer is option C. Thank you for watching. If you have further inquiry, drop down to the mail wingsofarrow@gmail.com. Thank you for watching and don't forget to subscribe to my channel for more updates. Take care, stay blessed.